So what we have now is f of x is 1 over x, and then we want to find its derivative using our rule and different quotient. Okay, which is the definition of a derivative. So in case of using the power rule, which is says of f of x as x to the n, then f of prime of x as nx n minus 1. Here, what we can do is we can rewrite this function as this way. Now we can use the power rule, which says this will go down, so minus 1, and then minus 1, minus 1. And that will be negative x minus 1 is minus 2. That's its derivative. Now let's use the limit definition. So f of x is equal to limit as h goes to 0 so this term here will be, from here we just substitute x by x plus h, so that will be 1 over x plus h. So here, let's go back. That term will be 1 over x plus h, and then minus 1 over x, and then over h. Now let's find common denominator. Now let's simplify these. So let's take them here. 1 over x plus h, and then minus 1 over x. Let's simplify these. What I'm gonna do is I'm gonna multiply this by this, then multiply this by x. Okay, that will be x, then x squared plus hx, and this term will be x plus h, and then x squared plus hx. So this term will be x squared plus hx, and then x minus x minus h. So this will be substituted here and here. And that will be equal to minus h x squared plus h of x. So now this whole term transfer to this term in here. So that will be minus h over x squared plus h of x over h. So this term with this term goes together, and what's left off is minus 1 over x squared plus h of x, which is equal to, oh, this is the limit. So this is as the limit of h goes to 0, limit as h goes to 0, limit as h goes to 0. Now, as h goes to 0, we will have minus 1 x squared plus 0, which is minus 1 x squared, which can be written as minus 1 over x squared, which squares minus x minus 2, which is the same as